Hey, and welcome everyone. I'm super excited to be here. We will talk about AI, MCP, and how to deploy it to Google Cloud Run today. So, this didn't update. Never mind. Okay. So we will do a very short presentation, then I do some live coding, and then we'll be having lots of time for questions. Okay, first things first, what is an agent? I think that's the question. It's coming up so much, a question everyone have. An agent is a system that uses a model to reason about and select appropriate tools to achieve a specific goal. So the important parts here are model. An agent uses a model. I guess everyone guessed that. We can't have an AI agent without an AI model, an LLM. But then what distinguishes just an LLM from an agent is the selection and the usage of a tool to achieve a specific goal. And that tool is exactly what we'll talk about today. So an agent has a model, the LLM, that's basically the brain of the agent that makes it think. And then what distinguishes it from just an LLM is the access to specific tools, additional things the agent can do, query, select to achieve a specific goal. All right, let's build an agent. How do we build an agent? Well, I'm going to cheat a little bit today and give you the agent building as the homework. We're going to use Gemini CLI today, which is an agent itself. So what is the Gemini CLI? The Gemini CLI provides access to the Gemini models in the terminal. Let's let that sink in for a second. The Gemini CLI provides access to the Gemini models in the terminal. So it's a way to interact with LLMs without leaving your terminal. And we're going to run Gemini CLI and my live coding in Cloud Shell. So it looks very similar to VS Code. You have your navigation on the left, you have your editor window at the top, and then at the bottom, you have a terminal window, and we'll just start up Gemini in there. Okay. So with Gemini CLI, once it's open and running, we can interact with the Gemini models. So we can ask it questions just like we're used to from any LLM. And I need everyone to be a little imaginative now because we're going to change gears a little bit. Okay, you're not in your office anymore. We're responsible today for IT at a zoo, and we're building a system that will share helpful information with the visitors. So forget your desk. Imagine you have lions and elephants and bears around, and we're working IT for the zoo to build a system for our visitors, like a virtual tour guide. Okay. Why am I taking us to a fictional zoo? Well, I want to make it very clear in the models what is the tools and the data that we provide versus what is the data that any LLM knows that web search provides to an LLM that the LLM was trained on. If I use anything real, all the information like say mathematics or well-known fact, something from a movie, that's all stuff the LLM was already trained with or that it could find via Google web search. So it will be very confusing in a tutorial to understand what is our data versus what is always available. So we are working with a fictional zoo. This is not real. This is not from a movie. This information doesn't exist anywhere else except what we give it for our proprietary fictional zoo. So hope everyone is willing to be creative today and pretend you're working for a zoo. It's gonna be fun, I promise. Promise. All right. So everybody feel grounded in the zoo? Can you hear the lions roar in the background? Okay. So we're in the zoo. We're going to ask Gemini CLI a question. Where are the penguins? Well, an AI system an AI agent is a system that uses a model to reason about and select the appropriate tools to achieve a specific goal. In this case, it's supposed to answer where are the penguins. And what model are we using when we're asking Gemini CLI? Well, Gemini CLI, as you can guess it, uses the family of Gemini models, multimodal models from Google that have lots and lots of capabilities. They're super powerful. But these models know nothing about our zoo. They have no idea what penguins we are talking about. So when we ask the Gemini CLI where are the penguins, it's going to ask the Gemini models via the Vertex API, hey, where are the penguins? And Gemini CLI is like, I have no idea. It's kind of like if I walked up to you and I'm like, hey, where are the penguins? And you have no idea what I'm talking about. Like, what penguins? Like South Africa, like from a movie, what sort of penguins? And Gemini CLI is in the very same spot here. So what we need to do to be a good IT department for our zoo and to build an agent that's actually useful for our visitors, we have to give it those magic tools. And I say magic because once you enhance an LLM with tools, you really have something magical that's so much more capable than just the LLM was before. All right, so in our case, the tool is going to be an MCP server, a model context protocol server that has that proprietary data about our fictional zoo. This MCP server actually does know where the penguins are. We will teach it where they are, so it will have that knowledge and it can be used as a tool. So when we ask Gemini CLI where are the penguins, it's asking the Gemini model, hey, where are the penguins? The Gemini model now says, for that information, I need to call the MCP tool server to figure out that proprietary data about penguins. So MCP extends the capabilities of a large language model. And that's really nifty. You don't have to spend a lot of time and effort fine-tuning a model. You, depending on the task, don't even need a very big model. You can do small, sustainable, more affordable, and then add MCP, and you have your capabilities massively extended. So the MCP server provides the Gemini model with a tool to find animals by species and a tool to find specific details about that animal. That's something we will implement in the MCP server. So Gemini now has those two tools, find animal by species and find details about an animal. Okay, so two tools in the MCP server that we can use. So as I said before, the agent, what's special about it is that it can select and use tools to achieve a specific goal. So our goal is still to find out about the penguins. We asked a model decides, hey, for this question, we need to use some of those tools. And so the agent is now going to use those tools. So from the description of the tool, Gemini can determine which tool to use. In description of the tool, that sounds pretty lofty, but it's actually straightforward in your code. Like it couldn't be easier. Here's a little snippet of our MCP server code. And you can see down here where it says get animals by species. It has this docstring here that is exactly that description that the LLM is going to use. So in natural language and plain text, we describe here, what does this function, what does this tool do? It retrieves all animals of a species specific from the zoo. Can also be used to collect the base data for aggregate queries of animals of a specific species, like counting the number of penguins or finding the oldest lions. And then we go on to describe the arguments and the return value. So this natural language description is what the LLM uses to determine if it should use a tool and with what parameters. All right, so Gemini decides, yep, I should use the tool. And now Gemini CLI will ask us if it has permission to use the MCP server, safety first. So there's some security built in, so it doesn't just call an MCP server that queries your bank account or something like that. So Gemini decides it needs to use a tool and asks for our permission to use it. We say yes, of course, because we gave it the tool, so it would have that specific information. So now we're calling the MCP server with a deterministic function. We're calling that tool get animals by species, and the parameters that we want to know about are the penguins. So we pass in species penguin. MCP server has the data and gives us back some JSON code with all the different penguins that are at the zoo. And that's basically the information we wanted. We said, where are all the penguins? And that's in that JSON blurb. But that's not super human friendly. And there's also a bunch of extra information like the names. So this JSON, with this data now, Gemini can answer the question. And we give it back to the model so that the model can transform this JSON blurb into a natural language answer to our question. So ultimately, it comes back with, you can find the penguins in the Arctic exhibit on the polar path. Okay, so that's quite a lot. But that's what I'll show you how to implement in the next 25, 35 minutes or so. So we will build an MCP server in Python, that thing on the left here that has all the information about our fictional zoos, our penguins, our lions, our location. And then I'll show you how you can use this MCP server with the Gemini CLI agent. And we'll also deploy this MCP server to Google Cloud. So it doesn't need to run on the same machine as your agent, and multiple different kind of agents can all use the same MCP server remotely in the cloud. Okay, and I said we're going to deploy to Google Cloud. What is Google Cloud? It's a serverless runtime. It comes with all the enterprise features you expect: scalability, built-in security, highly available. But the main reason I'm using it today is because it's so simple to use. Like, these are all buzzwords, and it's like, oh, cloud and workloads and agentic and serverless. But really, just remember, if you want to deploy to it, it's one click or one command, and you don't actually have to worry about that, but you still get all the benefits from enterprise cloud offerings. All right. Are you ready? Do you want to go build? If you want to follow along, you find the code lab that I'm going to work through on Google/AAI-WCR, Accelerate AI with Cloud Run -1. Google/AAI-WCR -1. Okay, hope everyone got that. And we'll send the links around after the webinar too. All right. Okay, so as I told you, we're working for a zoo. We're doing IT for a zoo, and we want to build an AI agent that'll be a tour guide for our visitors. And we'll build an MCP server in Python and deploy it to Google Cloud Run. I'm using the Cloud Shell editor, that is shell.cloud.google.com. It's a built-in editor, very similar to VS Code into Google Cloud, and it just runs in a browser. It's just a little easier for presentations because everything is in one place, and I won't be switching around between Terminal and VS Code. But what I'm showing you today totally works locally on your system too. You're not forced to be in the Cloud Shell editor in your browser. Okay, so Cloud Shell Editor has a terminal here, exactly the same as the terminal you're used to in VS Code or your local regular terminal. And let's dive right in. So we'll be building an MCP server with the two functions. First thing we need to do is to set up a Google Cloud project. I already did that, so let's skip over that. And then open Cloud Shell Editor. If you are in console.cloud.google.com, there's a little button at the top that brings you right into the Cloud Shell Editor. Or you do shell.cloud.google.com. Okay, and the first thing we need to do is we need to set our Google Cloud project. So mine is Fran Labs L200 today, and I'm using gcloud config set project, FranLabs L200. Okay, so, and we need this so that when we're deploying, it knows what credentials to use, or when we send a query to Gemini in the Vertex API, it knows what credentials to use. Okay, we need to enable a few APIs. By default, all APIs are deactivated in a new project, but we'll be using Run for Cloud Run, Cloud Build, and Artifact for our image that we're uploading. Okay, and now the fun part. So we're going to build an MCP server in Python. So I'm creating a directory and changing into it. So we're in this MCP on Cloud Run directory now. And I'm initializing a Python project with UV, using UV because I want to keep everything nice and tidy and not put anything in my global Python environment. So this created a PyProject.toml for us. And now we need to actually create the server. So the first thing we want is we want to add fast MCP. So UV add fast MCP. Fast MCP is a package to write MCP servers in Python. Super helpful. So we added this dependency. And now I'm opening a server.py file. So this is opening it up here in the editor window now. And I'm copying this implementation of our MCP server in here. So what do we have here? Well, import fast MCP because that's the package we're using. And we're creating a new MCP server here, the zoo animal MCP server. And then we have a long dictionary of animals at the zoo. So for example, species lion, we have a lion named Leo. He's 7 years old. He's in the Big Cat Plains on the trail Savannah Heights. So this goes on and on like this. So this is all the proprietary data that our fictional zoo has. And to keep things simple here, I just put it in memory in my MCP implementation. In any production system, that's probably what you're most interested in. All this data would be in a data store, would be behind a web API. It would not be right here in plain text like that. But this is Python code. So instead of saying, oh, here's my zoo animals and put it down as a dictionary, you would say, oh, here's my database, here's my credentials, here's how I connect, here's what I filter for. If you know Python, if you know how to get your data, it's just as simple as using this dictionary here. And then with this dictionary in place, we're defining the two tools, get animals by species and get animal details. So the get animals by species, as I showed you before, it has a docstring as a description. That's what the LLM is going to use to decide when and how to use this tool. And then it has an actual implementation that is hilariously short. It just says, okay, return animal for animal and zoo animals in this long dictionary if animal species to lowercase equals the input parameter to lowercase. So it's just filtering this dictionary for anything that has the same species. If you query this function with lion as the parameter, it's going to give you Leo, Nala, Simba, King. It's not going to give you Waddles and Pip because they don't match the species lion. Okay, so we implemented our server.py, our MCP server, and now we want to deploy this to Cloud Run. So the first thing I do is I copy into the wrong window. I create a Docker file. So Docker file, and in this Docker file, copying in this config here. I need a Docker file because I'm deploying a container to Cloud Run. So what we have here is we want a Python image, and we wanted to run the server.py file as our entry point. Okay, and now I promised you that Cloud Run is super simple, which is why we're using it. So I'm running this command gcloud run for Cloud Run, deploy zoo MCP server, region Europe West 1, source, current folder. And this is important, no allow unauthenticated. Do not allow unauthenticated access to this MCP server is what I'm telling Cloud Run here, because I don't want anybody in the world to be able to query it. That would potentially rack up my spend. I mean, this one is a read-only tool only, but there's MCP servers where you can add to a database or something. I think it's very obvious why we don't want access typically for anybody unauthenticated to MCP servers. Just like when you have a database, you want people to authenticate before they can use it. Okay, and while this is deploying, let's look at the second function in our MCP server. So the second function is get animal details. It takes a string and it returns a dictionary. It retrieves the details of a specific animal by its name. So the argument in that string is a name. So if you call get animal details with Simba, it would find out that Simba is a lion and return the details for the specific animal. Yep, so here for animal and zoo animals, it checks if the name matches the parameter, case insensitive, and then returns that animal where it finds that the names are equal. All right, and we are done deploying to Cloud Run, so I can control click on the server, yes, open. And just like I wanted, it's forbidden. Why did I want it to be forbidden? Because I told you I don't want unauthenticated access. So if anybody could just go to it and not get a 403, that would be a problem. So that's exactly what we wanted. We deployed it. And now let's see if we can use it. Okay. So I told you our agent is going to be the Gemini CLI agent today. Just skipping a step of writing our own agent, but it's a very easy way to make sure we can use an MCP server. So first thing we do, since we set it to not allowing unauthenticated access, is we're changing the identity policy where we're allowing this Google Cloud project access to it. And I need to export some tokens. I need the auth token here, and I'm storing it in the variable ID token. And now let's edit our Gemini CLI settings file. So replace all the context in here with specifying the MCP server. So we want to use the zoo remote server. This is the URL that we just got a little earlier when we ran Cloud Run. And this is the ID token where I just saved a gcloud auth token into it. Okay. So with all this in place, moment of truth, I'm starting Gemini CLI by just running Gemini. And start it up here. Guess my formatting is a little off. It should say Gemini in nice letters, but I'm only giving you half a screen. And one thing we see here right away is that it's using one MCP server, and I can hit Command T or I can do /MCP, and it's giving me information about this MCP server. And in fact, it says it has a configured MCP servers, green and running is the server zoo remote, it's ready. It has two tools, exactly like we configured it, and the tools are get animal details and get animals by species. So by adding the URL to the settings.json for Gemini CLI. We tell Gemini CLI, hey, this URL is available as an MCP server for you. We pass in our authorization here because we specifically locked down our MCP server. And so Gemini CLI, the agent, has access to the tools in this server. And we can get more information here, like we can do, oops, I'm always in the wrong window. We can do /MCP description. That gives us more details, for example, on each of the two tools. Like it tells us what the input arguments and the return type for get animal details is. All right. So now that our agent Gemini CLI is connected to our MCP server that we deployed to Google Cloud, we can say, where can I find penguins? And as I told you, this is a fictional zoo. This data is only available to us because we made it up. So it's not that the LLM was trained on it, that it can find it on Wikipedia or somewhere else on the web. This is specifically the data from our MCP server, from our data source. So we asked for penguins. The model decided, oh, for this specific information, I need to use the MCP tool, get animals by species, and it's asking us for permission. Yes, allow execution of this tool. And now the MCP server replies with this blob of information where it says enclosure, Arctic exhibit, polar path. And then the LLM takes this JSON, turns it into a sentence for us. You can find the penguins and the Arctic exhibit on the polar path. Okay, I think that's really cool. You just saw how to, with just a few lines of code, build your own MCP server, secure it, deploy it to Google Cloud, and then use this MCP server in Gemini CLI. You could double check now that it's really running, that was really using the MCP server. So we can run Google Cloud run services logs and check specifically for the zoo MCP server. And we would see here, okay, it got a request for it. It ran that query. We can also go to console.cloud.google.com, navigate to Cloud Run. And we see here is our zoo MCP server instance that we deployed. And this has an easy way to access the log files. We see some yellow here, some yellow warnings with the 4.3. That's when I open the URL in the browser to show you that you get unauthenticated 4.3 forbidden when you just try to open it. But we'll also see down here that it did call the tool get animals by species. So super simple deployment, but you get all the enterprise features built in, like these sort of log files, for example. Or if load is increasing, if your zoo is super popular because it's Sunday afternoon, everyone's looking where to find something, then Cloud Run would automatically scale up to accommodate that load if there is lots of queries all using MCP server. All right, cool. Let me find the right window. Where's my presentation? Sorry, I'm trying to get back to my presentation here. I might have closed it earlier. All right. So we built all this. Here's the URL if you want to try out this lab by yourself at a little slower pace, try different things, play around with it, see it in real life, not just when I presented. So we used Gemini CLI as our agent, but you can totally build your own agents, and that's where a lot more power lies. I would recommend using ADK, the Agent Development Kit, to build your own agent. So that gives you a lot more flexibility than using Gemini CLI, because Gemini CLI, by what the name suggests, is an agent living in your terminal. And we extended it by giving it an MCP server to make it a tour guide for the zoo. But typically, a real tour guide, you'd want an interactive UI, a web app. You would not want it in a terminal. So you could use ADK to build your own agent and connect it to this very same MCP server. You wouldn't have to write a new server.py. You wouldn't have to redeploy. You just give this URL to your ADK agent, and boom, it has access to the same data sources. So if you want to see that in action, go to Google/AAIWCR-2. So that's a tutorial for multiple agents written with ADK using the MCP server that we just deployed to Google Cloud. And if that's not enough and you want the real fun, we also have a tutorial, AAIWCR-3, for GPUs on Cloud Run. And it has a little load testing in it, and you can see how things are scaling up when the system's really under load. So that's a ton of fun. All right. I think it's time for questions.
Okay, we have a couple of questions coming in. I am going to be featuring them on the screen. Friend, let me know, are you able to see them?
And they're just a little tiny. Let me, okay. All right. So Maddie's asking, how can MCP be integrated into enterprise level systems to allow AI agents to securely access sensitive tools without compromising compliance? Oh, that's a very good question. So MCP is just a standardized protocol that gives you access to data. And if you have an MCP server that is serving or accessing sensitive tools, now the question is, how do you make sure only the right LLMs or systems are allowed to access that MCP server? And it's pretty much what I showed you. Like when you deploy it, for example, to Cloud Run, you have to make sure that you don't allow unauthenticated access. And then you have to figure out which systems should be allowed to access this Cloud Run instance. But you sort of have to implement the same security logic that you would implement in who is allowed to access the underlying information. So if you have a database and only specific users are allowed to access it, and now you build an MCP server to standardize access to this database, then you have to make sure wherever you deploy the MCP server, you only give the same users access who also had access to the database. Hope this makes sense. Okay, and Stephen Hope had another question. If it's not too early for questions, can Gemini CLI be scripted for automated workflow, or is it mostly interactive? Ooh, that's a good one. So the question is Gemini CLI, where you saw me typing in where the penguins and then answering yes to whether that tool should be allowed. So the question is, can Gemini CLI be scripted for automated workflows? You can start Gemini CLI with --YOLO, you only live once mode, which will allow execution of any tool. So this way you get rid of some of the interactive parts. And then you can call Gemini CLI from a bash script, for example, in a for loop or something if you want to repeat a certain LLM task multiple times. And yes, so long story short, yes, Gemini CLI can totally be scripted, which in my opinion is one of the big advantages of being in the terminal, because all the tooling you have from terminals, you can just apply and it works with Gemini CLI because it's just a command line tool. It's not like a web interface where you couldn't script it unless you use something to script your browser. So yes, it works also without interaction. Is there any page I can refer to create a simple agent? I would go to the second link here, Google/AAIWCR-2 for a very simple ADK agent. It also shows you how to write multiple ADK agents that interact, but they're all simple. Like, I think none of them has an implementation longer than one screen of code. So ADK for building your own agent is what I would recommend. It doesn't have all the bells and whistles that, for example, LangChain has, if you want to build an agent with that, but it has a lot more, in my opinion. It's much more developer friendly. The developer experience is much easier to get started with ADK, Agent Development Kit. Okay. Namdi has a question. Did you tell the model to always ask the MCP server any questions about the animals in the zoo? Oh, this is a really good question. So we have the MCP server tool with additional animal information for our fictional zoo. And we have the model that is super smart brains, knows when to ask Wikipedia, when to use the stuff it was pre-trained on. Now the question is, did I tell the model to use the MCP server, or how is that determined? So the LLM is instructed by default to use the MCP server if the question matches the description of the tools it has available. So since our description says animals, species in a zoo, any question you ask about animals will go to the MCP server. So when you ask it, how fast is a turtle? The LLM will say, oh, turtle, I have a tool for species. I probably should use the tool. And then our MCP server doesn't actually know anything about turtles because we don't have turtles at our zoo. So then the model would go back and say, sorry, I don't have information about turtles, which of course is a little silly because any LLM can answer general facts about turtles. So you could change your prompt and say, hey, how fast are turtles? Give me general information. Please look it up on Wikipedia. And in that case, it would realize to not use the MCP server. But by default, if a tool is available and the task matches the description, then the specific tool is used before the general pre-trained knowledge or Google Web Search. Yeah, but that's an excellent question. Okay, and Ravi is asking a follow-up question. How does the LLM know which MCP server to talk to if there are many MCP servers? So all the tools in those many MCP servers, and that's totally right. We can connect a tool to lots of MCP servers. We're not limited to one. We can have multiple data sources. All the tools will have descriptions and they're all loaded into the context. So the LLM will then make a judgment call which description is the best fit. So it depends on the descriptions for the LLM to know which tool it probably should be invoking. Okay, and George has a question. What changes would you recommend if our MCP has multiple tools and demand for them increases over time? So it sounds like you have one MCP server, multiple tools, and demand is getting bigger and bigger. If you deploy it to a source like if you deploy your MCP server to something like Cloud Run that scales automatically based on demand, that's what I would recommend. So if you have lots and lots of queries coming in, Cloud Run would just spin up another instance to serve up those requests rather than 429ing on some requests. Depending on the data, but I would have to see the actual use case. It might make sense to split the tools across different MCP servers, but if they're pulling from the same source, then it makes sense to keep them on the same MCP server. So yeah, I would say if you're expecting a lot of demand on your MCP server, make sure you're hosting it on scalable infrastructure. Like Google Cloud Run, if you really need a lot of sophistication, maybe even GKE, Kubernetes clusters. But Cloud Run covers like 99% of use cases, I would say. Great question. Oh, and Mary is asking the real question. To do these exercises, is there a cost? Yes. So since we're spinning up, yes, no, maybe. I think if you sign up for the free tier or if you sign up for a new account, you get a $300 credit anyways. But there's like $1 or $2 that those labs run. So I think a lot of times, like I did it with my personal account, I want to say, and did not end up incurring a charge. But we are sending a few questions to the Gemini API. That's like half a cent maybe. And we're spinning up a Cloud Run instance. Again, it costs almost nothing per hour, like a fraction of a cent. So there's a minimal cost to it. If you do Lab 3 with the GPUs, I think that costs a little bit, and I highly recommend doing the cleanup step at the end of the lab and taking it down. Yeah, so there's a tiny little cost associated with it. It might all fall into the free tier. It might be under the $300 sign up. But you're also welcome to reach out to me on LinkedIn or email. I think that information is shared after, and I can get you some free credits to try out specifically the labs. Like when we do this in person, we give everybody, I think it's a $5 voucher, and it's never exceeded by doing those labs. Yeah. But with LLMs, if we're not careful, the cost can go really, really high if you forget to secure your system, if you happen to have an LLM server that's public on the web and anyone can ask questions. There might be a bad actor who just spams it with millions of requests, and Cloud Run, since it scales so nicely, would scale up to handle that load, and then you wake up to a 3-4 figure bill. So always make sure you shut it down afterwards. You only allow authenticated access, and then the cost is very minimal as long as you don't have a lot of traffic. All right. Paula, are there any more questions we should cover? Okay, Andrew has a question. How would you compare and contrast MCP to ATA? What is the maximum number of tools or agents you think should be available when choosing from options to make a call? All right, MCP, Model Context Protocol, and A2A, Agent to Agent. MCP is how does my agent connect to tools such as databases and other APIs? So we have data sources, and MCP is the standard protocol that makes communication real nice and interchangeable from the data source with the agent. And then A2A is the agent-to-agent protocol, which comes into play if you have a multi-agent architecture. How should they talk to each other in a standardized way? So one is connecting one agent with a tool. And if you have an agent for a task and you have an agent for another task, how do you make those two agents talk together with A2A? And what is the maximum number of tools or agents you think should be available when choosing to make a call? Maximum number of tools. All the tools descriptions are in the context for the LLM. So that takes up space in your context window. So you're naturally limited at some point. And how many agents? Unfortunately, there's not a number. I cannot say 17 is your magic number. It's the same as microarchitectures. Do you want a monolith? Do you split it up into smaller agents that maybe represent, in some sense, the org structure of a company? Do you combine everything and then it's really hard to test and isolate? A small change affects everything, or do you encapsulate everything and at some point you have so many microservices, so many different agents that you don't know what works together? I would say start out with everything as one agent, and when you realize that gets out of hand, gets too complicated, then start splitting into multiple agent, start splitting the MCP servers. Maybe the MCP servers are already starting out as multiple ones because you naturally define them where your data sources are. Play around, do a lot of evaluation. There is sort of a sweet spot with how complex an agent should be. If it's too complex, it's really hard to get good answers. If it's too basic, then you have to do lots and lots of steps to get a major task accomplished. So it's trial and error. I don't have the optimal number for you, but keep in mind all the MCP subscription are in the context window, so that might be a limiting factor. I'm loving all these questions. Thanks, everyone. Suvanji is asking, are there any free platforms to practice MCPs and ADKs? I don't think there's one that's 100% completely free, but I do know Google Cloud does give you a very generous free tier to get started that covers like years of playing around and practicing and trying things out. Okay, and German is asking, can I have this AI bot take incoming and make outgoing phone calls for me for my business? I'm not sure if everyone is happy if you start calling them from an automated system. But since you're implementing your very own agent, there's lots of APIs that connect to phone call APIs that would allow you to make those phone calls. And you can certainly use the LLMs to take the voice as model input or to speak out any written output. So yes, you can do it, but you have to implement most of it yourself. Yeah, my phone strategy is to filter almost everything for spam and never having to answer any calls. Okay, Mary has a follow-up question. How does MCP ensure secure communication between the agent and external tools, especially in highly regulated environments like finance or healthcare? So MCP is just a protocol that makes it very easy to switch out agents or LLMs to use an existing tool. The secure communication part is still responsible to the person implementing it. So what I used today was the no allow unauthenticated flag with Cloud Run, which would secure it for me in that case. Yeah, but just like with non-AI implementations, you have to follow all the best practices and security guidelines when you deploy MCP. And Chris is asking, can you compare building agents with ADK compared to building them with LiveKit Gemini plugin for agents that answer or make phone calls? I have to admit, I have not used the LiveKit Gemini plugin. It sounds from this question like that might already have features for phone calls, in which case I would say maybe that's the right choice to go with. ADK is definitely very building something from scratch. The API is very developer friendly, but it doesn't have any no code or low code components. So yeah, sorry, I'm the wrong person for this since I don't know LiveKit. And Lingnon Cheng is asking, if I'm not a developer, can I do these exercises? I think it would help if you have some background with programming because you are writing a whole Python file, a little bit of being comfortable with the terminal. So when there's commands like mkdir or cd in the labs, you sort of understand, oh, that means make directory or change directory. In theory, you can very carefully work through the labs and see everything working. And that might be a bit of an introduction to developing for you. But I think the labs are easier if you have a background in coding. So they are intended as developer labs. And Harsha is asking, does not our pro priority data be compromised if we feed our data to Gemini or any other model? Okay, so I think the question is, are we training Gemini models or other models on the data we're giving to it? And that's a very good question, very important. Something to keep in mind whenever you use a chat LLM, anything you ask it could be compromised. Like if you don't carefully read what the chatbot terms of service say, the company might read it, or they might have implemented poorly. There might be a data breach and your data might get out. Just like when you sign up and there's a data breach and now your password is on the web, that could happen with data you feed into any chatbot. Google Gemini has its own terms of service, and we're not training on the data that you feed into it. But your company might have different guidelines of where you can use proprietary data and where you can feed it to, which APIs you're allowed to use with it. Okay, and Namdi is asking, is 10 agents, so 9 sub-agents and 1 root agent, too many for an agentic AI system? I would say no, that's reasonable. Yeah, that sounds very reasonable, I would say. And Mary, if we delete one of the tools in the MCP server and the agent has memory, would it get confused? Should we build into the agent checking steps to make sure that the tool and MCP server exists? Oh, that's a good question. I don't know how much the Gemini CLI agent is caching the MCP information. So we deployed our MCP server to Google Cloud. we changed our settings file for Gemini CLI to say this is the URL, and then we started up Gemini CLI. And I believe when we started up, it's querying what tools are available and caching those tools. And if we now redeploy a different MCP server, yeah, so I think if you have a sophisticated agent system and you expect the MCP server to just change quite a bit, you have to build in something to regularly update the MCP descriptions in the agent, or to have some sort of other checkpoint. I don't think we are not checking before every query because we already have in the context window what the description is. Okay, and Hotov is asking, where can we enroll in these labs? So you can do them at home yourself by just following those links, or we have an in-person event series happening in North America, India, and some parts of Europe through the fall. It's called Accelerate AI with Cloud Run, and I'll make sure to include the link in the follow-up communication. Those are free events, and we'll give out some credit so you can use the labs for free during the hands-on section of those developer days. Thanks for asking. And Carlos is asking, is it expected to be any official MCP server tools published at libraries to integrate with other system vendors? What is the path to that as like a package manager that install the tools? Oh, that's a good question. I come from the Node.js world, so obviously NPM and package management is very near and dear to my heart. And I think the package management and libraries we provide are oftentimes more important than the language itself. If there's no community around it, if the packages are hard to discover, it's really hard to use a language. And it's very much the same for MCP. And MCP is still so new, just a few months since Anthropic first introduced it. I don't think we have collectively settled on a standard. On a standard hosting system. There's a few that have sprung up and gone down. If you search GitHub, there's a few repos that call themselves the official list of MCP servers. I think that's something sort of wait and see until we've collectively, there might be that a foundation gets involved, that several of the major companies are part in, that we really have an official repository of MCP servers and also some sort of credibility, security, some sort of checking that the servers available there are not compromised. But for now, I don't think there really is the one and only official MCP server repository out there.